do. A lot of it's just evaluating stuff.
Okay.
Um,
Those are the kind I like.
okay, so the first one is g of x equals 5,000 times 2 to the xth power. And x is equal to -1/2.
So they want you to evaluate g of -1/2?
Yes.
That's what that would mean.
Mm-hmm.
In other words, it means plug in -1/2 wherever you see x. Okay.
Yeah, and I just put that into my calculator.
Well,
Right?
is it a calculator problem?
Yes.
Okay, then you can do it that way.
Mm-hmm.
Just plug it in as, up arrow -0.5. However, it's kind of important to understand, make sure you know what a negative exponent means.
Okay.
Okay? This is the same as this.
Okay.
In other words, here's what I'm saying. 2 to the -1/2 is first of all the same as 1 over 2 to the +1/2. That's what the negative exponent means.
Okay.
That's the same as 1 over square root of 2.
Okay.
Okay? Now, if you're going to give a decimal answer, do they want answers in decimal or in radical?
Decimal.
You sure?
Mm-hmm. Yeah. It
Because,
says evaluate the function and present the function in the round your result
well,
to the
that
nearest
doesn't
3 decimal
necessarily,
place.
they say round it off to how many places?
To 3 decimal places.
Okay. You're way ahead of me then.
Oh, sorry.
Typically, you don't want a decimal answer. You want a radical answer. It's the most precise. That decimal number you come up with is an approximation. It's rounded off, whereas what I circled there is not. The only
Okay.
problem with what I circled is it's not rationalized. Square root of 2 in the bottom is the same as 5,000 square root of 2 in the top all over 2, which actually becomes 2,500 root 2. In other words, if you
Okay.
wanted a radical answer, that's the answer.
Okay.
Okay? All right.
Okay.
What else?
The next one is a verbal problem.
Okay.
Okay. A computer virus.
Mm-hmm.
The number of computers infected by a computer virus increases according to the model. V times T equals 100E 100E to the 4.605T power, whereas T is time in hours.
Okay.
And first it says find V1. Second is find V1.5. And third, find V2.
Okay. Let me help you just a little bit with the terminology. When you're talking about that, that is not V times T.
Okay.
That's V of T. Much
Okay.
the same way that this is not F times X, it's F of X. In other words,
Okay.
over here, this means you have a function of X. It's not a function of R or Y or S. It's a function of X. On the other side of this, I'm going to find X's. Okay?
Okay.
So that's first of all. And then when you're referring to this, that's V of 1 and V of 1.5 and so forth.
Okay.
Okay? So how do I get V of 1?
You plug in V for T, or you plug in 1 for T.
Yes. okay, because we know it's a function of t. So don't be confused by that e. That e is just a number. That's all it is. It's not a variable. So in your calculator, you want to come up with this number. And you can get that straight out of your calculator.
Okay.
Okay. And then this one, you plug in 1.5 for t. And this one, you plug in 2 for t. 2 for
Okay.
t. That's a song. 2 for t? T for 2 is the song. Sorry.
That's funny.
Okay.
No worries.
I get you can kind of do that on your own. I don't need to.
Yeah, these problems today aren't too hard actually.
Yeah, no, they sound like they're not. Although we're probably going to get the one where we're going to have to use logarithms. In other words,
yeah, that's what I was.
So far the variable has been in the exponent. When the variable's in the exponent and you're substituting for that variable, you can do it with a calculator. But if you're solving for that variable, that's what's a little more difficult and where you have to use logs.
Today we went over logarithms, but I was kind of shaky on it. It's a little confusing.
Okay. Is that the first time you've had logs?
They've been presented in Algebra 2 and such.
Okay.
But not like this before. Yeah. Like now we're
No, you're right. Common Core, they give you a little bit of logs up until pre-calc, and then they give you the full slate in pre-calc. And it is a little harder, but we're going to need log. In other words, if I give you this following problem, you can't solve that algebraically. You can't even solve it in your calculator.
Okay.
Right?
Yeah.
However, I can solve it if I use logs, because the one thing about logs is that I can take the log of both sides, and now by applying the laws of logs, I can bring that exponent and put it down on the algebra line, so that now I've got this. And now I can solve it algebraically, because all I have to do is divide both sides by log of 2. Again, these are just numbers.
Okay.
Okay. You're still going to use your calculator to solve for x, but x would be the log of 7 divided by the log of 2. And you can get that number out of your calculator.
Okay.
So when you're solving for the exponent, know that you're going to have to use logs most of the time. Unless it was 8 equals 2 to the x, now I can figure out that x is 3 just if I know, 2 cubed is 8. But it's not usually that easy. In other words, usually you're going to have to use logs to solve those kind of problems. So what's the next?
Okay. We went over natural logs, and I didn't quite understand those. Like,
natural logs are pretty straightforward. If I do not put a base, if I say the log of 5, that presumes base 10. In other words, that presumes there's a 10 there. Okay? If I want log base 17 of 5, I write it like that.
Okay.
If I want log base e of 5, I write that like this. So whenever you see natural log, it merely means log base e. What is e?
Okay.
E is an irrational number. In other words, it goes on and on forever, but it can be approximated by 2.71. It's a lot like pi. Pi is 3.14, and it goes on and on forever. Well, e does the same thing, but both of them are just numbers.
Okay.
Okay. And your calculator has a key for that. Now, when you get to calculus, natural log is the language of calculus, far more than common log.
Okay. We talked about common log a little bit, but she didn't really go into depth with that.
The only thing about common log is what kind of calculator do you have?
A TI-84 Plus.
It only has 2 log keys on it. One is
Okay.
log and the other is ln. The log means common log and the ln means ln. In other words, if you want this from your calculator, you have to use the change of base. That happens to be equal to the log of 5 divided by the log of 17. So you
Okay.
still get that from your calculator, but you have to do a calculation. That's
Okay.
not the reason that natural log is so important. Natural log is important fundamentally to calculus. You end up,
Okay.
when you're using logs in calculus, 99% of the time it's natural log. Okay? So
Okay.
on that previous problem where I said 7 equals 2 to the x, well, my tendency is I'm always going to use natural logs. I'm going to take the natural log of both sides. Then I'm going to bring down the x. So x is going to be the natural log of 7 divided by the natural log of 2. And you may say to yourself, well, how is that true? Because I just told you that it was equal to the log of 7 divided by the log of 2. Those two ratios are exactly the same. That is the
Okay.
same as that.
But isn't the one on the right log base 10 and the one on the left log
It is. They're
ln?
all the same. And in fact, that's the same as log base 17 of 7 divided by log base 17 of 2. In other words,
Oh.
base does not matter when you're looking at these ratios. You're right.
Okay.
That's common log, base 10, and that's common log. That ratio, you could check it, but you can take my word for it. That ratio is the same as this ratio and the same as this ratio. It's just
Okay.
I use natural log because that's what I always use. Because of the calculus. You get used to
Uh-huh.
working with natural log, and there's no reason to ever use common log.
Okay.
I shouldn't say no reason. There
But
are
little
some
reason.
applications like earthquake Richter scales that are based on common logs. So it's not like common log isn't a part of the real world. It is. But
Mm-hmm.
all of your calculus uses natural log for the most part.
Okay. Okay. Well, I mean, other than that, that's pretty much the extent of my homework. I only had those two problems left. I was wondering if we could work on some SAT problems, maybe?
Yeah, we can for sure. And I'll pull those up. Let me just give you the 3 most important rules for logs, just to
Okay.
get you just a little ahead of the schedule here. If I have the log of 2 numbers multiplied together, that's the same as the log of A plus the log of B. Very,
Okay.
very important. All 3 of these are. If I have the log of 2 numbers being divided, that's the log of A minus the log of B.
Okay.
And thirdly, most important of all, is if I have the log of a number being taken to an exponent, that's the
Mm-hmm.
same as that exponent times the log of A. And I say that's the most important one. You'll notice that's how we end up solving all exponential equations, is this third rule right there. That's what
Okay.
allows me to get the exponent down on the algebra line. I can't solve
Mm.
it as long as that exponent is, in other words, as long as the variable is in an exponent. I can't solve it. But if I can get it down to the algebra line, now I can solve it algebraically. So these
Okay.
3 rules, you're going to have to know these, and I mean backwards and forwards. In other words, they're going to
Okay.
give you tons of problems where you have to expand an expression. In other words, you have to go from the left side to the right, and they're going to give you tons of problems where you have to condense expressions. In other words, if I
Okay.
said, what's the log of x plus the log of y? Well, that's the same as the log of x times y. That
Okay.
would be condensing. Expanding would be if I gave you the log of xy, you'd separate it into the log of x plus the log of y.
Okay. Why is that? Why is it like plus in the multiplication
Same
in the
reason
same?
that exponents are like that. Remember that logs are exponents. That's what they are.
Okay.
Okay, and if I told you that x to the a and I multiply it by x to the b, what do you do with those exponents?
You add them?
Exactly.
Oh, okay.
Okay, and if I told you that x to the a raised to the b power, you multiply those two numbers.
Okay.
Okay, and because logs are exponents, they follow the same rules as all of our rules for exponents. In other words, if I have x to the a divided by x to the b, well, that's the same as x to the a minus b. So
Okay.
division becomes subtraction, multiplication becomes addition, and double exponentiation becomes multiplication.
Okay.
And that's the way to remember it, actually. Notice, oops, I already advanced, sorry. Um, that's the way I try to get people to memorize it, is that you're always doing one level less than what the problem is doing. One level less than multiplication is addition. One level less than division is subtraction. And one level less than exponentiation is multiplication.
Okay. So if I had a log, say I had log base 17
Uh-huh.
um, of 4
Mm-hmm.
raised to the log base 17th power, how would that be like? Would those add?
Well, first of all, you can't have a log without an argument. So
Okay.
this expression here doesn't have any meaning unless I put an argument in front of it. In other words,
What's
if
an
I put a
argument?
4, now, yeah, exactly. I can take this entire exponent, which is just a number, log base 17 of 4 is a number, and put it
Okay.
in front. In other words, I bring it down and stick it there. So this becomes log base 17 of 4 times log base 17 of 4.
Okay.
That's a number. You can get out of your well, you have to use the change of base to get it out of your calculator. But if you got
Yeah.
a newer calculator, they will let you use bases other than 10 and E.
Okay.
Okay? But yeah, exactly. You can, no matter how complicated that expression, let's say I had the log of 5 to the x squared minus x over x minus 1. That's my exponent, okay? Well,
Okay.
I can take that entire exponent and drop it in front of the log so that it becomes x squared minus x over x minus 1 times the log of 5, which is just a number.
Oof. Okay. So are log bases ever added?
The bases have to be the same. In other words, these rules that I laid out don't work if I have the log base 3 of x plus the log base 4 of y. I cannot combine those two. That is not equal
Okay.
to the log of x times y. You can only do those three operations if your bases are the same.
Okay.
They
So
always
what do
will
you
be.
do if your bases
They
aren't?
won't mix you up. Well, your school might mix them up on you, but in general, you're not going to be confronted with that. I don't even know how to handle it if they give you a mixture of bases. There's just
Okay.
no way to compress that. As opposed
Oh, okay.
if it was log base 3 of y, now that can be compressed to log base 3 of x times y.
But that won't be log base 6 of x times y. That'll just be log base 3.
Be log base 3. The only time I can compress or expand or do any of those three operations are if it's the same base. And then the base
Okay.
stays the same. You don't.
And bases are usually the same.
Yeah, they stay the same. You don't add them, multiply them, or anything else.
Okay.
Okay. All right.
Okay.
Should we pull up that SAT?
SAT question?
Yeah, that same practice test that we were working on before.
I'd love to.
I remember we got through number 11, if I remember right. And we've got 2 of these, so.
And this is good because I take the SAT on December 2nd.
Oh, okay. Yeah.
So in just about like less than 3 weeks.
And if we get through these 2, I can find more. All of the ones, I have a ton in my in my computer. I got like 11, but they're the old SAT test.
Okay.
They're not the new one for 2016.
Okay.
Not that there's a huge difference. I mean, if we were desperately looking for SAT practice problems, those would be fine. But obviously, we're better off if we can use a test that is part of the design on the 2016 test. Yeah, we did that one on the right. Remember that one?
Yep.
This excellent example of looking at the answers before. Let me say one more thing about question 7.
Okay.
If we don't look at the answers, we might really go off on a path here where we could burn 5 minutes really easily.
Okay.
If you look at the answers, the possible 4 answers, you realize that none of them have anything multiplied together. They're not, multiplying these 2 together at all. And in fact, if we look at the answers, we start seeing everything that's in the question. And then it becomes relatively straightforward to work out that, it's all I need to do is multiply both sides by the entire denominator and divide both sides by the entire numerator. And that's when we...
And so P becomes B.
Yeah, it's B, and it's not only that, but it's a 20-second problem instead of a 10-minute problem.
Okay.
Whereas if you start right off, cover up these answers, and you start off, you'll even remember when you looked at it, you were trying to figure out P, N, and all what each one of them meant.
Yeah.
Which was a waste of time because they're not pertinent to the problem. You don't need to know that P is the payoff of the loan or R is the percent or any of that. That's meant to confuse you. That they give you all of this information strictly to confuse you. Why else would they do it? Why don't they just say solve this for P? I could eliminate this entire paragraph and say solve for P. So this paragraph is meant to confuse.
To confuse?
Yeah, absolutely. It's its only purpose. Right, we did 11. All right, let's start with 12. Hold on a second. Let me, some of these I want to have my other screen open also. And I can still blow that up a little bit bigger. All right.
Okay, a line on the XY plane passes the origin of the slope. Which of the following? Oh man, these are always. I think it's B 1 7, 1 and comma 7.
Well, let's not guess.
Okay.
First of all, what's the equation of a straight line? What's the format that you know the best?
Y equals X. Or Y equals MX plus B.
Right. There's 3 of them. There's slope-intercept, which is this. There's point slope, which is different. And then there's standard, which is different also. This is the one they first teach you, y equal mx plus b, where m is the slope, b is the y-intercept.
Okay.
Okay, so read the first line, passes through the origin, and has a slope of 1/7. What's the equation of that line?
Y equals 1/7 x plus b.
Plus 0. If it goes,
plus 0.
B is 0. If we're going through the origin, in other words, going through the origin, means the y-intercept is 0.
Okay.
Okay? So we can come up with the entire equation of that line. Now, to figure out which of these points fits that equation, it has to fit that equation. In other words, when I plug in the first number for x, I better get the second number for y. Well, does 0,
Okay.
work?
What? Sorry, I didn't catch that.
0, 7 does not work, right?
No.
When x is
No.
0, y would be 0. Well,
Yeah.
how about when x is 1? Y would be 1/7. So that doesn't work. When x is 7, y should be 1. That doesn't work.
Yeah.
When x is 14, y should be 2.
Okay.
Okay? So whenever they're giving you which of these points passes through or which of these points is on this equation, it has to satisfy the x and the y. Okay? If I told you and then I gave you a point, and that's the equation of a circle, okay?
Yeah.
And I give you a point, and I said, is it on the equation of that circle, or the circumference is what that means. In other words, the circle has a radius of 4. When I say, is a point on that circle, I mean, is it on the circumference? And it's only on the circumference if the x and the y coordinates satisfy this.
Okay.
Okay? So x of 1 and y of 6 don't satisfy this. So those 2 points would not be on the circle. However, notice that 4, 0 does.
Okay, yeah.
Because 4 squared plus 0 squared is equal to 16. So that point's on the circle. Also, 0, 4 is on the circle. Negative 4, 0 is on the circle. And 0, negative 4 is on the circle. As well as lots of points in here that don't have quite as, in other words, they're going to be irrational numbers. But the essence is when they're asking about a point being on an equation, it has to satisfy the x and the y of that equation.
Okay. Okay.
Let's look at 13, which is down below here.
If x is greater than 3, which of the following equations is equivalent to 1 over x is greater than 3.
Well, the way to handle this problem is you have to be able to know how to solve this. Multiple choice or not, x greater than 3 or not. You need to be able to add those 2 fractions in the denominator.
Isn't it?
Because we cannot flip. You cannot flip and multiply until you have a single rational quotient.
Yeah, that's what I was just doing,
Can't do
x squared.
I can't flip and multiply it by x plus 2 over 1 plus x plus 3 over 1.
No, okay.
Multiply once I've finished adding these 2 things together.
Okay.
How do you do that? What is...
you just multiply them. You multiply them by each other, so it becomes...
Well, yeah, you have to find a common denominator, right?
Yeah, and then you multiply each side by each other.
All right.
Yeah.
What's the common denominator going to be?
X squared plus 5x plus 6.
Here's the way that I think it should be done, and a student introduced me to this, and it was genius. In other words, the common denominator is that, and don't multiply it together yet.
Okay. Just
write it as a common denominator. When you're dealing with variables, it usually is the product of the 2 variables. Okay? Now, over here, we have to put a numerator that does not change this fraction. Well, what numerator does not change that fraction?
X plus 3.
Yep. And now we can really see that we have not changed it.
Oh,
I could cancel out that x plus 3 with that x plus 3, and I would still have 1 over x plus 2.
okay.
It's a beautiful method here. And over on the right side, what do I have?
X plus 2.
Yeah. Now, there's a more formal way of getting this. What you do is you divide your common denominator by the x plus 3, multiply it by the numerator, and you get this answer, or rather
Okay.
x plus 2. But this little technique works really great because you can instantly prove whether you've changed the fraction or not. And that's the whole goal, is to not change the fraction. Now, what does that equal to? Now that I have a common denominator, I can add the numerator.
2x plus 5.
That's in the numerator.
Over x plus 2 times x plus 3.
Yeah, and whether or not I need to multiply that out or not, now I'll look at my answers and see. In other words, now what we're looking at is 1 over that, right?
Mm-hmm.
So now I can flip and multiply. In other words, whether I multiply these out or not, I basically have it in the form of a single rational quotient. So the answer is going to be x plus 2 times x plus 3 all over 2x plus 5, or having those multiplied together. Let's look at the answers and see which ones they have. Well, they
Would be x b.
Yeah, it would be b. In other words, they did go ahead and multiply them together. But notice that because it's multiple choice, I don't actually have to do that multiplication. I can look at the answers and tell, well, it's got to be b.
Because 2x plus 5 is in the denominator.
Yes, and the only other terms we're looking at here are, there's an x squared plus 5x plus 6, and here's an x squared plus 5x plus 6. So you know that x plus 2 times x plus 3 must equal x squared plus 5x plus 6 without actually doing it, because they've given it to you in all the answers except C. So you know what that multiplies out to by looking at the multiple choices. Now, they said one other thing here. If x is greater than 3,
Okay.
why did they say that? Because I didn't...
Is it just another thing to confuse?
I didn't need any conditions on x. Notice what x cannot be. X cannot be minus 2. X can also not be minus 3.
Oh, okay.
So if I didn't have this restriction, then B would be my answer, but I would also have to say something to the effect that x can't be minus 2, x can't be minus 3, and in fact, x cannot be 5 halves or minus 5 halves, because now we've violated from down here the restriction of dividing by 0.
Okay.
So whenever you're given a problem like this, these domain restrictions do not go away just because we manipulate the expression. In other words, up here I've got a domain restriction of minus 2, x can't be, and minus 3, x can't be. And then I pick up another domain restriction here, x can't be minus 5 halves. Well, they take care of all three of those restrictions by telling you x has to be greater than 3.
Okay.
That's the only reason. It's a bit confusing. You're almost better off ignoring that because it really doesn't have anything to do with the solution. If I crossed that out there and they just said, which of the following 4 expressions are the same as this expression, the answer is still B. I don't need x to be greater than 3. I just need x not to be minus 2 and not to be minus 3 and not to be minus 5 halves. But so that's why they put that there. But again, it's almost more put there to confuse you.
Okay.
Not relevant to solving it, really. Notice
Okay.
that when I went through the solution, I never even considered it.
Uh-huh.
All right.
If 3x minus y equals 12, what is the value of 8x to the x over 2y? Don't I have to have a common denominator here to determine the value?
Well, this does at first glance look like a problem that can't be done. In other words, first of all, I cannot solve for x or y, right?
Okay.
Two variables
Yeah, no.
equation. And second of all, they're asking about an expression that is an exponential expression, not an algebraic one.
Uh-huh.
But it's a special exponential expression. Let's talk about these. Let me give you a
Okay.
theoretical problem. If I said 8 to the x was equal to 2 to the x plus 1, can you solve?
Isn't that oh, I don't
It's an
I could
exponential
do two,
equation, but it involves numbers that share a common base.
so I could do 2 to the
Yes, I would do.
2 to the
That's,
cube, 2
that's the
cubed.
way I would write 8.
Yeah.
It's
2
still going to
cubed
be to
x
the x equal.
equals 2x plus 1.
Now use your properties of exponents to simplify the left side.
So 3x
2,
equals,
2 to the
oh, sorry,
3x
2 to
equals
the 3x.
2 to the x plus 1. And now, because I have same base in the bottom, I can equate the exponents.
Yeah, the one-to-one property, right?
Yeah, exactly. In other words, next thing would be 3x equals x plus 1, and that you can solve that.
Mm-hmm.
Okay. Well, this problem is similar. Notice that 8 and 2 have this same common base. So how am I going to write this expression over here?
2 cubed to the x power over 2y.
Now simplify the numerator.
2 cubed to the x power times.
Simplify the numerator by multiple. What we have here is double exponentiation.
Oh, okay.
So it's just
2
3x.
3x
Okay.
over 2y.
2 to the y. Now we got same base.
Okay.
So that has to be equal to what?
2 3x over y.
3x minus y. Remember,
Oh, minus y.
when we're doing division, we subtract the x.
Yeah.
Well, now we have something we can work with. They want to know what this is. Well, they've given us an expression that tells us what 3x minus y is equal to.
Oh, it's 12. So 2 to the 12.
2 to the 12. Exactly.
Okay.
Okay.
Oh.
So a problem that doesn't look like it really can be done, turns out that this expression ends up with a 3x minus y as an exponent.
Okay.
Okay? Or if it ended up with 6x minus 2y, we'd be able to figure out. But if it ended up just being x minus y, we would not be able to answer this.
Okay.
Because it doesn't tell us what x minus y is, and we don't have any way of figuring it out from this. There's no way you can take this equation and tell me what x minus y is. In other words, you cannot isolate x minus y all by itself with a number on the other side.
Okay.
So I think
That's
15 is up here. Whoops.
Okay. Oh.
Okay.
If a of plus 2 times b of x plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b equals 8.
Okay.
What are the two possible values? Is this a system of equations?
We don't know yet. I don't know yet. First of all,
Okay.
this looks hard, complicated. I don't understand any part of it. So what's the first thing we should do?
Maybe multiply out ax
Exactly.
plus 2
In other words,
times
whenever
bx
you
plus
find
7.
yourself in that situation where you don't really understand the problem all that well, there's not a whole lot to be done other than to multiply those two together. That's really the only starting spot. So multiply
Okay.
those two together and tell me what you get.
Abx squared plus 7ax plus 2bx plus 14.
Okay. Now we're told that that's equal to that. Okay.
Okay.
Well, I can combine those two middle terms. Might not be obvious that I can, but I can. Here, I'm going to rewrite this as abx squared plus, I'm going to factor out an x just between those two terms, and I'm left with
7a plus 2b.
b. Okay, now we're getting somewhere. Now,
Yeah.
if all of this is equal to all of that, we can equate terms. So I've got what? 15 equals AB. Now let's write it like this, right?
Yeah. Okay.
7A plus 2B has to equal what?
C.
And
14 equals
third
4.
equation, that's what the
A plus b.
A plus B equals 8.
8.
Okay. Well, notice that I got 3 equations and 3 unknowns. What
Okay.
that tells me is I'm going to be able to solve it for C.
Okay.
Okay, now let's talk about how we do it. You're right, it is a system of equations. Let's see, can I solve for C?
Could you subtract c and bring it over to the left side of that middle equation?
You could. I don't think that's quite the way to go.
Okay.
In other words, if we try to solve it by elimination, there's going to be problems. It's not going to be as easy because we have these two being multiplied together and everything else is being added or subtracted. If
Okay.
we know, in other words, here's the two equations that we can solve for A and B immediately with just substitution. Just from those two equations, right?
Mm-hmm.
In other words, if A plus B equals 8, then A equals 8 minus B. Substitute that for A, so I have 8 minus B times B equals 15. Well, I can solve that. That's going to be a quadratic. That's going to give me B squared. I'm going to move it to the other side. Plus 8b, so minus 8b, plus 15 equals 0. You with me on the right?
Yeah. Yeah. Okay.
Okay. In other words, I distributed the b, and then I moved both of these terms to the right side of the equation. And then I switched all three of them back to the left, because whenever we have a quadratic, we want 0 on one side.
Yeah, and the quadratic on the other.
Yeah. Can you factor that?
So that becomes b minus 3 and minus 5.
Okay.
So
So
b
B
equals...
has two different solutions.
Okay.
And now we know, first of all, when B is 3, A is 5, and when B is 5, A is 3, right? So let's put both of those. So A is 5.
Oh, so
or 3. In other
And
words,
you could plug those back into your...
yeah, now we can plug these all into this middle equation for C and come up with 2 possible values for C. Well,
Okay, so
7
you
times,
can...
I'm going to use this for one solution and that for another solution,
Okay.
because they're different solutions. Even though it's the same 2 numbers, they're different solutions. Okay, so let's start with the top one. When A is 5 and B is 3, we have 35
7.
plus 6 equals C. So C equals
Mm,
41. When A is 3 and B is 5, we have 21 plus 10 equals C, which is 31. So there should be 2 values for C, D.
31, 41. Oh, okay.
So that's, and notice that Y substitution was easier than elimination.
Yeah.
This is not really in standard format up here because you have the A multiplying times the B. So if I go to try to solve these using elimination, I got some big problems. It's going to be
Yeah.
really hard. How do you eliminate something when I got A times B minus A doesn't eliminate anything?
Mm,
So it's not easy to solve by elimination, but it really was quite easy to solve by substitution.
okay.
The thing I guess to look for when you're solving it by substitution is we really only have 2 equations involving just A and B, the first and the third. And 2
Mm,
equations, 2 unknowns, you can solve that by substitution easy enough. And then once you get your 2 possible values for A and B, it gives you 2 possible values for C.
okay.
A good question, actually. Fairly tough, but
Yeah.
again, the toughest part of all is probably figuring out how to get started.
Yeah.
But once again, when you come across a problem that you don't know where to start, start wherever you can. In other words, you just start
Okay.
by doing, if there's only one thing you can do on the problem, go ahead and do that. And then see where
Okay.
that leads you. And, okay, now we get to the part of the test where you have to grid in the answers. You're familiar with that?
Yeah.
Okay. These tend to be a little easier,
Mm-hmm.
I think. Just because they don't give you multiple choice, they make them a little easier.
Okay.
This
So,
one's really easy.
yeah, that one's...
How do I solve this?
If t is greater than 0, t squared minus 4. Don't you just set t minus 4 equal to 0 and then solve for t?
Yep, go ahead and do that.
Um, t squared minus 4 equals t plus 2 and t minus 2.
I like the way of solving that by factoring. That's not the normal way to solve it, but I'll tell you one huge advantage in solving it like that.
Because then you can see the plus and the minus 2.
Exactly. Whereas if you solve it by moving the 4 to the other side, in other words, if I solve it by trying to solve this, well, it's really easy to make that mistake.
Mm-hmm.
Not equal to 2, it's equal to plus or minus 2. Whereas when you solve it by factoring it as difference of perfect squares, you can't make that mistake.
Yeah.
Now,
Okay.
in this
How
particular
would I...
case, they said t has to be greater than 0, so what is our answer?
2.
Right.
Oh, okay.
So, in other words, you could have used the easy way to do it, and even if you made a mistake, you'd have been right.
Yeah.
But most everybody makes this mistake. They leave out the plus or minus.
Okay.
Sometimes it matters, sometimes it doesn't. In this case, it wouldn't matter.
It
But
wouldn't have mattered.
sometimes it will. If you leave it out, you'll not get the right answer.
Okay. Oh, man. These problems.
Well, So all this is a similar triangle problem.
This is geometry.
Yeah, well, you got a point there. You're 2 or 3 years removed from geometry.
Yeah.
The most important part of similar triangles is corresponding parts are similar.
Okay.
In other words, if I have a 30, 60, 90 right triangle,
Mm-hmm.
whose dimensions are 1, square root of 3, 2, and I have another triangle over here that's just a bigger version of it. It's still 30,
Okay.
60, 90, and this side is 2. I know that whatever the similarity ratio is between these two triangles, it applies to all 3 sides.
Okay,
So
yeah.
if this one is twice that, then the hypotenuse has to be twice this hypotenuse, and this side down here has to be twice.
Okay.
So that's the principle I'm going to use on these two similar triangles. Now, how do I know they're similar? Because they have
Um,
angles that are the same.
yeah. Don't they have vertical angles? Isn't that?
Well, those are 2.
Oh, but
In other words, that angle's equal. I don't know if you can see where I'm pointing there, but
yeah.
these 2 angles here are equal. And they tell us that this angle, E, is equal to angle D. Well,
Okay.
2 out of 3 means 3 out of 3 when you're talking triangles, right?
Yeah.
You can't have 2 angles equaling one another without the third one being equal also. So A is also equal to C. That means they're similar triangles. 3 same angles equals similarity.
Mm-hmm.
Okay? So what they're giving us here are some dimensions, and they want to solve for x. Well, let's do a quick draw here and label it. This is something else that you kind of have to answer for yourself, is how much should you draw pictures to try to understand a problem. And unfortunately, they've given us all the information in a paragraph instead of labeling. If they labeled the diagram, they would take 60 seconds off the solution.
Yeah.
Okay? Well, those 4 sides are these 4 distances.
Okay.
AB, so let me label, in other words, I can do what they could have done to make it easier. EB is
Mm-hmm.
1400.
Yeah.
BD is 700. And CD is 800. So,
And if
and
B,
this angle here is equal to this angle here. So
so doesn't that?
the corresponding side for BD on this triangle. If this triangle 1 and this triangle 2, which side corresponds to BD in triangle?
E to B.
EB, exactly. In other words, you have to make sure this angle ends up on top here, which means this side ends up on top there. So what's the similarity ratio?
Uh, 2 to 1,
Yeah, and I
or
always
1 to.
like the big to the small. Some geometry teachers will go small to big, which is just as proper, but then you're dealing
Okay.
with fractions. You don't want to deal with fractions. You want 2 to 1. So what's X?
X is 1600.
Yeah. Real simple if they gave you the drawing. Made
Okay.
much more complicated by their entire paragraph of words.
Yeah. Oh, you are a little bit easier.
Yeah, they will be, I'm quite sure. Even the old test had grid problem. We got time for one more, I think. Yeah,
Yeah.
try to do this. I got at 6 o'clock, so I'm going to have to run at 6 precisely. But
Oh, no worries.
now, on this one, we can solve these by elimination. But notice there's no XY combination. It's
Mm-hmm.
X's and Y's only, always being added or subtracted. How can I solve this by elimination without doing anything else?
You could subtract equation 1 by equation 2.
Correct. What do you get?
Subtract equation 1 by equation 2. You get negative y equals, add 25, 16.
Uh-huh.
So y equals 16.
Y equals negative 16.
Or y equals negative 16.
Okay, now I can figure out what x is. What's x? In other words, now I take my solution for y and plug it into either equation and solve for x. So x minus 16 equals minus 9. What's x equal?
X equals 7.
That's the answer.
Okay. Cool.
Now,
thank you.
Yeah, just notice one thing about that. They wanted x, so it would have actually been a little quicker if I could have eliminated y, but I can't eliminate y without multiplying the top equation first.
Yeah.
So I like your solution where you eliminate x, solve for y, and then once you've solved for y, you can go back and solve for x. They're probably about equal in terms of length or time to do, but
yeah.
All right, Nick, have a good week, and I'll talk to you. Let's see, you have a Thursday set up at 4. I'll talk to you Thursday.
All right. See you, Mr. Cohen. Thank you.
Bye-bye.